Hello, my dear students. In the last class, I explained about composite bars and solved one problem also, right? Today, we will see other different type of numerical. Before that, you just make a note. Like sometimes we come across a set of two or more members supporting a load. Okay, composite bar is it's always like that. It is made up of two or more different materials. In such cases, the deformation of all the members will be the same. This one I have already told. Just you recall these things. If the members are of different cross sections or have different modulus of elasticity, then the stresses developed in all the members will be different. So this point you have to remember. Okay, if the members are of different cross sections or have different modulus of elasticity, then the stresses developed in all the members will be different. Then you have to find what are the stresses developed in each bar. Okay, then the second concept is same. The total load is equal to P1 plus P2. Okay, it is the summation of two or the more the different materials. Okay, so we will solve one problem. One example. Okay, a block shown in figure weighing 35 kilonewton is supported by three wires. Okay, the outer two wires are of steel and have an area of 100 square each, whereas the middle wire of the aluminium and has an area of 200 square. This. Okay, if the elastic moduli of steel and aluminium are 200 GPa and 80 GPa respectively, then calculate the stresses in the aluminium and steel wires. Okay, this is the given example. So it is a bar made up of three different materials, but two are of steel and one material is of aluminium. Okay, it the total load is 35 kilonewton. Okay, what is given? Total load is 35 kilonewton. So 35 into 10 raised to 3 newton, and total area of the steel rods. Here there are two steel rods are there. That's why I have considered 2 into 100. Area of the steel is 100 square. Okay, so 200 square. Then area of the aluminium rod. What is the area of the aluminium rod? That is 200 square. Okay, then modulus of elasticity of steel, ES, that is equal to 200 GPa. Yeah, modulus of elasticity of steel is 200 GPa. It is 10 raised to 9 Newton per meter square. If you convert it into millimeter, it becomes 200 into 10 raised to 3 Newton per millimeter square. Similarly, E of Young's modulus for aluminium is 80 GPa. 80 into 10 raised to 3 Newton per millimeter square. Okay, the load supported by the wires, that is the total load, is equal to 35 into 10 raised to 3. How we can calculate? Here you have to calculate the stresses in the aluminium and steel wires. So sigma S you have to calculate and also sigma A you have to calculate, right? How you can do that? We know that formula, right? I have told first only you have to remember the 2 points in the case of composite section. What are those points? The first point is deformations are same, and second point is the total load is equal to the sum of the load shared by the different materials. Okay, let us take sigma S is equal to stress in the steel wires and sigma A is stress in the aluminium wire. L is the length of the wire. Here what happened in this case, the length is same. You can see here the length of the steel aluminium is same. Okay, so what you can write? First you write deformation for steel. Okay, what is deformation of steel? Delta LS is equal to, what is the deformation formula? Delta L is equal to PL divided by A into E, right? So this is deformation is equal to PL divided by A into E. right? So A into E. So this P divided by A, that is nothing but stress. So that's why here it is written as sigma S. Okay, sigma S into this L. L is still for this LS divided by ES here. Okay, is equal to sigma S into L. L we will take because the length of the steel and aluminium all are same. So just I'll consider L divided by ES. Young's modulus for steel is 200 into 10 raised to 3. Okay. Then similarly deformation for the aluminium. What is the deformation of the aluminium? That is sigma A into LA. Why this is sigma A? Because deformation is equal to PL divided by A into E. So this P divided by A is equal to sigma. So sigma of aluminium into LA divided by E into A. But again L is same for aluminium and steel. So sigma A into L divided by Young's modulus for aluminium is 80 into 10 raised to 3. Okay. So substitute that according to that what I have told in the first only theory, since increases in the lengths of the steel and aluminium wires are equal, therefore equating equations means deformations are equal here. Because of that, delta LS is equal to delta LA. So what is delta LS? Simplify this, sigma S into L divided by 200 into 10 raised to 3 is equal to sigma A into L divided by 80 into 10 raised to 3. This is why, because deformations are equal, that is delta L of steel is equal to delta L of aluminium. Okay, so if you simplify this, you can write in terms of either sigma S or in terms of sigma A. Anything you can write. I will write in terms of sigma S. So sigma S is equal to this 200 into 10 raised to 3 goes here divided by 8 into 10 raised to 3. This L get cancelled. This will get cancelled. Okay. So what you will get? You get sigma S is equal to 2.5 times of sigma A. Okay, sigma S is equal to 2.5 times of sigma A. Okay, this you will get. This is sigma S. This is sigma S. So, second rule, what it says, total load is equal to the load taken by the steel plus aluminium, right? So, total load is equal to, what is that formula? P is equal to here, P of steel plus P of aluminium, right? P of aluminium. So what is this P of steel? P is nothing but we know stress is equal to load divided by area, right? So P is equal to C into A. Okay, sigma into A. So but that is for steel here. Steel is sigma S into AS plus P of aluminium bar, that is sigma A into AA. Substitute, what is sigma S? Sigma S is equal to this 2.5 times of sigma A. Substitute that into 200 area of steel, that is here I have given first only. Area of the steel is 2 into 100 because two steel wires 1 and 2. So two steel wires, that's why it is 200 mm square. Okay, next simplify this 200 plus what is sigma A? Sigma A is we don't know, so let it be like that, into area of the aluminium. What is the area of the aluminium bar? That is equal to 200. Okay, substitute that. So you simplify, only one unknown here, sigma A is the unknown, so is equal to, you will get 700 sigma A. So you know total load P is equal to 35 into 10 raised to 3. Substitute that. So Now 35 into 10 raised to 3 is equal to 700 sigma A. So you get sigma A is equal to 35 into 10 raised to 3 divided by 700. So simplify this, you get sigma A is equal to 50 Newton per mm square or 50 MPa. Once if you know sigma A, you can calculate sigma S. What is that? Sigma S is equal to 2.5 times of sigma A, right? So substitute that sigma S is equal to 2.5 times of sigma A. Okay, so sigma A. So substitute this value of sigma A, you will get 125. So stress developed in the aluminium bar is 50 Newton per millimeter square, and stress developed in the steel bar is 125 MPa or Newton per millimeter square. In this way, you can calculate the stresses developed in the steel bar and aluminium bar. Okay, so mainly you have to remember 2 points. The first point is deformations are equal, and second point is total load is equal to P1 plus P2, or whatever. If it is steel means PS plus P aluminium is PA. Okay, once if you know that, you can equate the equations. Means first write the deformations. Deformation is nothing but PL divided by A into E. So P divided by A is nothing but stress. Simplify, you substitute that, and both the cases like that, and then equate that, you will get one equation, right, in terms of either sigma S or sigma A. Okay, once if you get that, then second apply the second rule, that is total load is equal to PS and plus PA. Substitute that, only one unknown you will get. So so you will get that stress in the aluminium or steel, then substitute that value in this equation. Okay, you will get the stresses in the steel bar. So in this way, you can find what are the stresses developed in the composite bar. Okay, thank you.